This video is all about drip rate calculations. So if you are asked in a med math exam to calculate drops per minute, this is a video that's going to teach you how to calculate that. But before we actually get into that formula, let's understand in what situations we would have to make that calculation. So here, this first picture is a picture of an Alaris pump, an IV pump. Where you work might have different brands of IV pumps, but Alaris is a really common brand. And you usually set these to run in milliliters per hour. So the physician will say he or she wants normal saline, 75 milliliters per hour. For some medications, you don't set it to milliliters per hour. You might set it to micrograms or whatever the case might be. But a lot of the time, you are setting it to milliliters per hour. So that's what an Alaris pump is. This one, number one, has one channel attached, and it's channel A right here. My second picture, number two, this one actually has four channels attached. It has A, B, C, and D. And you can program each one separately. So this patient is getting four different medications. Looks like they're getting heparin through A, dopamine through B, I think potassium through C, and insulin through D. So this person is getting four infusions. And that's usually, most of the time, depending on where you work, how we get IV fluids into people using a pump. So to use an IV pump, you need a special piece of equipment. You need this IV tubing, which is right here. And if I was going to draw it out, there's a spike at the end, and that's what you spike the IV bag with. And then there's a drip chamber. So drops of whatever your IV fluid is come down into the drip chamber. And then there's a line and kind of a special part of the tubing there with a clamp there. And then the line here, and then a roller clamp right around there somewhere. And then it goes off to the patient. So that's what the IV line looks like when it's all stretched out. There's one part of this that we feed into the IV pump, and it's this part right here. And then we close the door, and then we program the IV pump. And it's through this piece of the tubing that the machine controls how many milliliters per hour the patient is getting. So we put that into the pump, and then we program the machine. And that's how it looks when it's set up. We have our IV bags hanging. This person has one channel connected to the Alaris pump. And it's hard to see, but there's the roller clamp right there. And that's how we get IVs fluids into people. Now, let's say you didn't have an Alaris pump because it was a really busy night shift and they were all in use. Or you transferred a patient to a different floor and the IV pump went with them and that was your last IV pump, or whatever the case might be. You don't have an IV pump, but you need to get IV fluids into a patient. And the doctor has made an order for however many mils per hour, but you don't have an IV pump. All you have is your bag of IV fluids. Let's say it's normal saline, and your line with your drip chamber. You have a clamp right there that normally sits in the machine, and then you have the roller clamp right there. That's all you have. Well, you can still get IV fluids into somebody without having an IV pump. So I'm going to draw that out again. Here's my bag of normal saline. I've spiked it. Here's my drip chamber, my line, the roller clamp, and then it goes off into the patient. So I can actually manipulate this roller clamp right here so that this drip chamber drops a certain amount of drops per minute, and I can deliver a certain volume of fluid to the patient that way. So the doctor is going to order it in milliliters per hour. But I can use a formula to figure out how many drops per minute that is. So I can deliver this without programming a pump. I can just manipulate this roller clamp so that the line is more wide open or not as wide open. And the normal saline is dripping down into this chamber and continuing down the line and eventually getting to the patient. And that's the drops per minute. So this is the calculation we are learning to do in this video. We are learning how to turn milliliters per hour into drops per minute. And let's use a formula to help us. So the formula we're going to use is drops per minute. That's what we're trying to get, is the mils per hour. So that's what the doctor has ordered, times the drop factor. And I'll explain what that is, over top of time in minutes. And that's going to be 60 minutes because it's milliliters per hour we're changing. So this is what we're trying to solve for. We're trying to get the drops per minute. The mils per hour is what the doctor has ordered. And what about the drop factor? Well, this is easier to explain if I make this chamber a little bit bigger. So I've spiked a bag of normal saline, and here's the normal saline there. And I've made the chamber bigger than it normally is. And then off it goes to the patient. And drips fall down and fill up this chamber and then fill up the line. Well, the drop factor is recognizing that this part of this equipment is different sizes. So in some equipment, it takes 60 drops to make 1 milliliter. So literally, it takes 60 drops of fluid, 60 of those, and you can see them falling down into the chamber to equal 1 milliliter. 60 drops equals 1 milliliter. There's other types of tubing where it only takes 15 drops to equal 1 milliliter. So you only need 15 of these. So obviously they're going to be bigger. 15 drops equals 1 mil. And when it takes 60 drops to make 1 milliliter, this is called micro drip tubing. So if you have an exam question and the exam question says you have micro drip tubing, it is 60 drops per mil. If you have an exam question that says you have macro drip tubing, macro drip, it is usually 15 drops per mil, but just to confuse us, macro drip isn't always 15 drops in 1 milliliter. Sometimes you will have macro drip that's 10. Of course, sometimes you'll have 15, so I'll just put that here. And sometimes you will have macro drip that's 20 drops per mil, which means, again, it's going to take 20 drops of liquid, 20 of those to equal 1 milliliter. Now, when you look at the back of your IV line packaging, it will always tell you the drip factor. It will always say how many drops per mil. So in your class, when you are coming up to exams, ask your instructor, when they say macro drip, what do they mean? Do they mean 20 drops per mil? Do they mean 15? Do they mean 10? Because macro drip is defined as any one of those three things. So that's what micro drip and macro drip are. Micro drip, the drops are really, really teeny tiny, and you need more of them to equal 1 milliliter. Macro drip, the drops are bigger, so you need less of them to equal 1 milliliter. So let's do a practice question to make sure that we understand. Let's say that the doctor has ordered, so our doctor's order is 75 mils per hour of normal saline. and we don't have an Alaris pump, but the doctor wants this started right away. You grab an IV line and you see the IV line that you have stocked is 15 drops per mil. So we need to figure out how many drops per minute to make sure our patient gets 75 mils an hour. So let's put it into the formula. So this is going to be 75 because the doctor has ordered 75 mils per hour. And we're going to times that by the drop factor. We've looked at the back of the package. It's 15 drops per mil. And we are going to divide that by our time, which is going to be 60, because the doctor has said 75 mils per hour, which is 60 minutes. So to solve this, it's 75 times 15, which is 1,125 over 60. So now we divide 1,125 by 60, and we get 18.75 drops per minute. Well, when we're counting drops falling into a drip chamber, we can't count 18.75. We can't get a fraction of a drop. So if you ever get a decimal when you are solving these, round to the nearest whole number. So this one's going to be 19. So that's our final answer, 19. Which means when you take this equipment into the patient's room and you are getting it set up, that means that you are going to be having one hand on the roller clamp, because the roller clamp controls the flow. It controls the flow of the liquid through the line. So if the roller clamp is closed, no liquid is going through the line. If you open it up a little bit, some liquid is going through the line. And you can see how much liquid is going through the line when you look up at the drip chamber. So when you go to program this, you're going to be standing there with one hand on the roller clamp, kind of watching your watch with one eye and watching the drops with another eye. And you're going to count and make sure 19 fall down in 1 minute. And then you know the patient is getting 75 milliliters per hour. So you might be counting for 30 seconds and already be at 20 drops. Okay, that means you have to close the roller clamp a little bit. So you are going to spend some time in there adjusting the roller clamp until you have it exactly right, until you have it at 19 drops per minute. So it can take a little bit of time to set up, but that's how you do it. You're watching the drops fall down into the drip chamber and you're controlling the flow with the roller clamp. Here's an example question from an exam you might see in nursing school, or a question you might see in nursing school. Doctor has ordered D5 half normal saline, 20 kCl, 50 mils an hour. You have macro drip tubing, and this macro drip tubing happens to be 12 drops per mil. How many drops per minute is the question? Okay, let's put it into our formula. So we are solving for drops per minute, and our volume is 50 mils per hour. I got that from here, 50 mils per hour. My drop factor is 12 drops per mil. And I got that from here, 12 drops per mil. And I'm going to divide it by 60. And I know it's 60 because the doctor has ordered per hour, and there's 60 minutes in 1 hour. So to get the answer to this, I go 50 times 12, which is 600. And I'm going to divide that by 60. So this one's pretty easy to solve. 600 divided by 60 equals 10. So 10 drops per minute is the answer to this question. And just to make sure we understand the roller clamp and everything again, here's the spike, here's the drip chamber, there's the line, and as the line continues, I have a roller clamp down here, which literally means I roll something over the top of the line and it squishes the line down, so that would be closing the clamp. Here's my bag of normal saline that's spiked. And so I'm going to go in and make sure that 10 drops fall down per minute. 10 drops per minute. That's the answer to the question. And that way I know the patient is getting 50 mils per hour, which is what the doctor has ordered. And here's another question. So doctors ordered 75 mils an hour. We have macro drip tubing again. This time it's 20 drops per mil. So remember, macro drip can be a variety of different things. It could be 10, 12, 15. It could actually even be 20. So this one happens to be 20 drops per milliliter. How many drops per minute? Well, let's put it into our formula. Drops per minute is going to be the volume. So 75 times the drip factor. And in this case, it's 20 drops per mil divided by 60. So to get the answer here, I'm going to times 75 by 20, and that is 1,500. And I'm going to divide that by 60. And so my answer is going to be 25 drops per minute. Let's do one a little bit more tricky. So this time the physician has ordered 500 mils normal saline over 2 hours. Our tubing is 15 drops per mil, macro drip tubing. What is the drip rate? Okay, we don't have the mils per hour. We have 500 mils over 2 hours. So this is going to be 2 steps to solve this. The first step is we have to convert to mils per hour because that's the way that our formula works. So we have 500 mils over 2 hours. So basically we just divide that. 500 divided by 2 equals 250. So that means 250 mils per hour. Okay, so we've converted it to mils per hour, and now we are ready to do our formula, our drops per minute formula. So that's our total volume. In this case, it's actually going to be 250, not 500, 250 times 15 divided by 60. That's going to be 3,750 divided by 60. And so our answer is going to be 62.5. So of course we can't put 62.5 drops into somebody. So the final answer to this is 63 because we round to the nearest whole number. And when it's a 0.5, we go up. So meaning if it was, let's say the answer was 62.3, then my answer would be 62. If it was 62.4, my final answer would be 62. 62.5, it's right in the middle, so you may think, well, do I go down or do I go up? When it's 0.5, you go up. So the answer to that would be 63, and that's why our final answer is 63. Here's another question, and in this question, we're going to need 2 steps to solve it. So here we have the order for Ringer's lactate over 6 hours. Our previous question was a certain amount of milliliters per hour, meaning per 1 hour, but now we have a certain amount of milliliters per 6 hours. So there's actually 2 different ways that we can solve this. The first way that we can solve it is that we can figure out how many mils per hour is 750 mils in 6 hours, and that's just dividing. 750 mils in 6 hours. All we do is divide 750 by 6, and we have 125 milliliters per hour. So to put that into our formula, so we'll just draw an arrow because we're putting that number into our formula to get drops per minute. We have 125 mils per hour times 20 drops per mil divided by 60. And that's my time in minutes because I have figured out 750 mils in 6 hours is actually 125 mils in 1 hour. So that's why I can have 60 at the bottom, because 60 minutes is 1 hour. So to solve this, to answer this, 125 times 20 is 2,500. And we divide that by 60. And the answer is 41.6. Well, that can't be our final answer because we can't count 0.6 drops. So we're going to round up to the next whole number. The correct answer is 42. That's one way to solve this problem. There's a second way to solve this problem. Let's say I don't want to figure out how many mils per hour is 750 mils over 6 hours. I don't want to bother figuring that out. Well, I can actually still put this into my formula without doing that calculation. So what I would do instead is I would figure out how many minutes are in 6 hours. So 60 times 6. So I'm figuring out how many minutes are in 6 hours, and that's 360. Okay, now I can go to my formula. So I do drops per minute equals, now this time it's going to be 750 times 20 divided by 360, because I didn't change anything to mils per 1 hour. I stayed with mils per 6 hours, the amount of mils over 6 hours. So here I would go 750 times 20. So that is 15,000 divided by 360. And guess what the answer is? 41.6. And our final answer is going to be 42. So I got the exact same answer. In the first option, I figured out 750 mils over 6 hours is how many mils over 1 hour. That's what I did in the first option, but I still use the same formula after that. In the second option, I figured out how many minutes are in 6 hours, and then I used the formula. So either way, I got the correct answer. And either way, you can get the correct answer, whichever one you choose to do. Okay, we have a nurse that's ordered to infuse 300 milliliters of normal saline over 90 minutes with tubing with a drip factor of 15, still on macro drip tubing. What's the drips per minute? Okay, so we have 300 mils and it needs to go in over 90 minutes. So what we can do in this case is easily use our formula. Drops per minute equals 300 times 15. That's the drip factor. And this time it's going to be over 90. In almost all of our previous questions, it was over 60. With the exception of the last question, I showed you a different way to solve it. And so in this question, we don't have to convert anything. We don't have to do anything because we have the time in minutes. So we can put 90 minutes there. So to solve this, we're going to go 300 times 15, 4,500 divided by 90. And the answer is 50 drops per minute. Let's do one more practice question. Normal saline 1 liter over 2 hours. Macro drip tubing, 20 drops per mil. What's the drops per minute? Here's another question where there's 2 possible ways to answer it. So the first way to answer this is to figure out, okay, if 1 liter is going in over 2 hours, how many milliliters are going in over 1 hour? And that's just simple division. So 1,000 milliliters. So I've converted liters to milliliters, are going in over 2 hours. So that means I have 500 mils per hour. And now I can go to my formula. And my formula is drops per minute equals the volume. So 500 times the drop factor, which is 20, over the time. And remember, I've converted it to 1 hour. So I'm at 500 per hour. I'm not doing 1,000 mils over 2 hours. I've converted it to how many mils in 1 hour. So it's going to be divided by 60, not divided by 120. So to solve this, 500 times 20 equals 10,000 divided by 60. And that is 166.6, which means 167 drops per minute. That's the first way to solve it. Second way to solve it is, instead of converting 1 liter in 2 hours to milliliters in 1 hour, I can just convert the 2 hours to minutes, and of course the liter to milliliter. So let's see how that works out. So 60 times 2, because I have 2 hours and I want to figure out how many minutes are in those 2 hours, equals 120 minutes. And now I can plug this into my formula. So I know that 1 liter is 1,000 milliliters. So I'm going 1,000 milliliters times 20. And this time I'm dividing it by 120 minutes. So 1,000 times 20 is going to be 20,000. And I'm going to divide it by 120. And of course, the answer is 166.6, which of course is a final answer of 167. So the first way I solved this, I converted 1 liter in 2 hours, because that's what the question stem gave me, into 500 milliliters in 60 minutes. And those are the numbers I used for my formula. In the second option, I converted 1 liter in 2 hours to 1,000 milliliters in 120 minutes. So that's going to give me the exact same answer. And I would say whichever way you choose to do it is fine, as long as you don't feel confused about which way you're doing it. So just some key things that I want to leave you with. So just a few things that I want to leave you with so you don't find these questions too confusing. And to show you, I'm actually going to draw our formula out twice. So remember, we're solving for drops per minute. And so it's going to be mils per hour times drops per mil divided by time in minutes. And I'm going to draw out the exact same thing again. Mils per hour times drops per mil over time in minutes. So the first way that I solved this question, I figured out how many milliliters in 1 hour. So my question stem told me 1 liter in 2 hours, but I figured out how many milliliters in 1 hour. So it was 500 in 1 hour. And at the bottom of the first option, I had 60 minutes. So I had 1 hour at the top, 500 mils in 1 hour, and 1 hour at the bottom in minutes. In my second possible way to solve this question, I just stuck with what I had in the question stem, although of course I converted it to milliliters. So in this case, I was solving for 1,000 milliliters, and I knew that was in 2 hours. And at the bottom, I had 120 minutes, because 120 minutes is 2 hours. So I had the amount of fluid for 2 hours at the top, and I had the amount of minutes for 2 hours at the bottom. So whichever way you solve it, just remember that your amount of time has to match at the top and at the bottom. If you have 500 mils in 1 hour, then you should have 1 hour at the bottom in minutes. If you have an amount of fluid for 2 hours at the top, then you need to have 2 hours at the bottom in minutes.